once we know our general formulas or our general reactions, then we can actually start working out how to balance the equation. Now I've started by giving the formula of some things here. Now if I'm not very good at balancing equations, that's a pretty awkward place to start. So actually what I'm going to do is I'm going to rewrite their names underneath them. And I'm going to write them with the cation, because these are both ionic, the cation on the top and the anion on the bottom. I'm doing that on purpose. Okay, so I'm going to go aluminium sulfate plus sodium hydroxide. The reason I'm doing this, because I've seen, oh yeah, I know this is a precipitation reaction. The reason I know, by the way, is they're both ionic compounds, and while this is a base, this one isn't an acid. Okay, so I know it's just a precipitation reaction. So what I'm going to be able to do there is I can grab the anions and swap them over. Because it's a precipitation reaction, I'm going to grab those two names and trade them to become my products. I'm going to swap them over. So I end up with, whoops, okay. Now technically speaking, sodium sulfate isn't made. It's sodium ions and sulfate ions in solution, because all sodium salts are soluble in water. So it's not actually making any sodium sulfate crystals at all. But it will make aluminium hydroxide crystals. There's a bit of a confusion with this until we add lots and lots and lots of this, and then something else really cool happens. So now I've got my word equation. I find it much easier now to do you might have heard the phrase drop and swap. So I'm going to use my ion table, or my knowledge of ions, or my periodic table to write the actual ions symbols out. So I know that I've got aluminium, which is Al3+, and I've got hydroxide, which is OH negative. Well, actually, to cancel these 3+ charges out, because compounds are neutral, there's no charges in these, they're compounds, I need a few more negative charges, because at the moment this has got a charge of +2. So I need to add another hydroxide and another hydroxide. Now I've got 3 negatives. Now some of you might do the drop and swap. You take the 3 from there, drop it here and put it over here. I find that risky because I sometimes forget to put brackets in place for writing a formula. So by writing it out this way, which looks a bit daft, but actually writing it out this way will make me write it properly. I've got 1 aluminium and I've got 3 hydroxides. Well, how can I show that there's 3 of the whole thing? What do I use? Brackets, okay? So I've got hydroxide, hydroxide, hydroxide. That's what 3 times something means in general mathematics. Okay, so that would be the same as something like 3x. That's what it means. I've got 3 of them there, I'm just counting them. Get rid of that. So I've got my formula. Sodium sulfate, sodium is in group 1. So as we discussed the other day, that means Na+. Sulfate is one I'd hope you'd know off by heart by now, which is SO42 negative, but if you don't, that's okay. Again, the overall charge of this thing at the moment is -1. It's a compound, you can't have a charged compound. So you have to get it back to neutral. So I'll add another sodium to go with the sulfate. Now, unlike the hydroxide, I don't need brackets around my sodium because the little letter means it belongs to the N as well. It's Na, it's not N, an atom of N and an atom of A, it's an atom of Na. This, however, means an atom of oxygen and an atom of hydrogen that have to hang out together. They're not allowed to be split up. They have to hang out together. Alright, so I don't need brackets in this, but I do in this one. So I've got 2 sodiums, so it becomes Na and then a little subscript 2, SO4. So now I've got my equation. I'm nearly ready to balance. Well, actually, I am ready to balance. Okay, so I can put those 2 up here. And you'll notice that I like to keep things in columns of things that are the same. I just find it easier for getting my head around while I'm learning something. Once I've learnt it, I get incredibly chaotic and messy with this and basically just write the answer. But while I'm learning it, I take the time to write the words. I take the time to write out the ion charges. I actually take the time. Once I'm good at it, I can just get straight into it. But while you're learning the process, do it the slow way. Right, up here. How am I going to balance that? That is just all over the place. 2 aluminiums, 1 aluminium. 3 sulfurs, 1 sulfur. 13 oxygens, 7 oxygens. It's all over the show. Where on earth can I start? Any ideas?
On the aluminium, I'd just chuck a 2 there real quick.
Fantastic. So when we're doing this, now we've got the formula right. We're not allowed to mess with the formula. We're only allowed to mess with the numbers of them. And numbers are big numbers in front of them. So the big numbers that go here. We're not allowed to change any of these little numbers. They are fixed. They're stuck. So I change pen. I actually change colour on purpose, because that makes me leave the blue stuff alone. I'm not allowed to touch my blue stuff. It's right. It's correct, because, see, it's all correct. I've got it right. So now I'm going to use my black pen, because in our assessments you're only allowed to use black and blue. So I'm going to use my black pen to balance it. I know the equation's right, I just need to balance it. Aluminium is a great idea. We've got 2 here and 1 here, so I need 2 aluminium hydroxides. I need 2 of that whole compound. So I put a 2 in front. That also helps lift my number of oxygens, because remember they were a real problem before. Okay? But it doesn't do everything for me. Okay, so I like starting with the metals as well. I think it's a really good place to start. Is to start with the metal ions when we're doing precipitation. I'll warn you now, we're not going to be finished just by leaving that as a 2. It's not going to quite work, but that's okay. If I look at the sodiums, there's how many on the right-hand side? 2, because 1, 2. And how many on this side? The reactants? Just 1. So I could put a 2 here, couldn't I? This is getting hard because that hasn't balanced it for us. Okay? We're on the right track though, we're doing really well. Actually, what we're going to need is 3 of these. Can anyone tell me why I need 3 of these?
Because you got 3 H's.
Great. The H is it. And what I'm going to suggest to you is treat, because it's a precipitation reaction, treat this aluminium as one thing, it's one thing, Al3+. Treat sulfate as another thing, because see it stayed as sulfate over here. Sodium is one thing. And hydroxide, see it stayed as hydroxide? It didn't actually get broken up. The OHs are hanging out together. So you can treat it as a hydroxide. And so very well done by going, oh look, there's 3 hydrogens over there, so there has to be 3 here. It means we actually need 3 hydroxides on the left-hand side. But what's that going to do to our sodiums?
There's 3 aluminiums.
If I go 3 here, that's why I like having the whiteboard, what does that do to my balancing the sodiums? You can't do it, can you? Or can you? How could you make something that's got 3 and something that's got 2 work out?
You could put a 3 in front of the sodium sulfate and a 2.
So that will give me how many sodiums on the right hand side? 6, great. So I'm going to need 6 here. That means I've got 6 hydroxides. So what is that what I've got here? 6 hydroxides?
Yeah.
So it's actually worked out really well. Okay? So my advice to you here, my teaching for you here is, with ionic compounds, treat the ion as an entity. Okay? So if you need to give it letters, A, B, C, and D, and then work with them as A's, B's, C's, and D's, and then put their actual symbols in. Okay? We're nearly there, actually. This is great. So we've got our 6, we've got that, we've got our 2. How many sulfates on this side? 3. How many on this side? 3. So it's suddenly It's one of those, aha moments. It was really hard, and then suddenly, it broke open. The thing we're actually looking for is the fact that you had for the sodium hydroxide on this side, you had a 2 with it there and a 3 with it there. The only way you can do that is to have 6, what we call the lowest common multiple. So if you're ever having trouble balancing something, find what it was made from. Okay, there's 3 of them, there's 2 of them. 3 times 2 is 6. Give me 6 of the starting thing and then start balancing it from that. This is one of the hardest ones you'll get. So if you can do that, that's awesome. The ones that I did in the last bit of teaching are a lot easier. Okay, combustion, because combustion's another one that we should have a look at. So if I've got methane and oxygen, because combustion, although it's with air, we say it's with oxygen because nothing else in the air is actually reacting with it. We've said that a combustion reaction always makes which 2 compounds? Perfect. So CO2 plus H2O. Okay. The first thing that I like to do is actually check that my carbons are balanced before I start. Because if they're not, then that's the best place to start. So that's my first check. Are the carbons balanced? Yes. Awesome. So I probably don't have to do a lot with that. Are the hydrogens balanced? No. So there's 4 here, 2 here. What am I going to do?
Put a 2 in front of the H2O.
Cool. And again, I've changed my pen. 2 over here. Okay. How many oxygens on this side? 2. How many on this side? 4. Good. Because now I've doubled that. It's become 4. So I need 4 here. How do I do that? 2 O2s. Great. The combustion ones are quite easy. Start with the carbon. Then my suggestion to you is do the hydrogens. Then do the oxygens. Then check the carbons. And if they're still right, then you've got it. Okay? If they're not right, just go through that process again. Carbons, then hydrogens, then oxygens. Back to the start. Check the carbons. Balanced? Yes, you're finished. No, start again. Rebalance your carbons, rebalance your hydrogens, rebalance your oxygens. You should be done by now. Okay? Should only take 2 times through with a at the most for a combustion one. All right. So recap. Your process has to start with knowing what's made. I suggest using a blue pen to write that down. Don't change it. Then when it comes to balancing, change your pen colour so you're leaving the blue stuff alone. You're not changing anything. That's the biggest mistake people make. Is they change formulae. You're not allowed to. So you use your black pen to balance your numbers. If you've got ionic compounds or metals, balance the metals first because they're usually the easiest ones to balance and then go from there. If the ions don't break apart into their constituents, so their atoms, then treat them as one thing because it will make them easier. If you find an impossible situation where you've got, say, sodium hydroxide has 2 sodiums there but 3 hydroxides there, multiply those 2 numbers together so that you can work out how much of the reagent you needed and then balance after that. And that's basically your process in a nutshell. Are there any questions on that before I turn this off? It's a lot to absorb, I know.